Welcome back to the Military Breakdown Podcast. Today, we're really getting into the B-21 Raider. It's the U.S. Air Force's brand new stealth bomber. And this thing is, well, it's not just another plane. It's billed as the world's first sixth-generation aircraft.
That's right. It's set to completely redefine long-range strike.
So we're going to unpack what that actually means for the future.
Yeah, this isn't just a small step up. It's genuinely a generational leap, like you said. The B-21, it's engineered as a dual-capable, penetrating strike stealth bomber.
Dual-capable meaning?
Meaning it can handle both conventional and nuclear munitions. It's really designed to be, the absolute backbone of the bomber force for years, decades, probably.
Alongside the B-52.
Exactly.
Yeah.
Working in tandem with the B-52. And what's really interesting, I think, is how the program focused from day one on adaptability, affordability, and crucially, producibility, making sure they can actually build these things at scale.
Affordability and stealth.
Yeah, historically, those two words haven't always played nicely together.
No, they haven't. So what's different here? How are they focusing on producibility with the B-21?
Well, a really key decision Northrop Grumman made was to build the test aircraft on the exact same production line they'll use for the main fleet.
Okay. So learn as you go, basically.
Precisely. That early integration, figuring out the build process, it's given them invaluable data on how to manufacture efficiently and scale up later.
And we're seeing results from that approach.
Definitely. I mean, the fact that the program hit production lot 2 back in Q4 of 2024 shows they're moving along.
Right.
And there was that recent $4.5 billion injection, too. That really signals the commitment to getting this program accelerated.
Okay, let's zoom in then. The B-21 itself. What are the core characteristics we should know?
Fundamentally, it's a nuclear-capable, penetrating strike stealth bomber. It falls under Air Force Global Strike Command.
And the numbers? How many are they planning on?
The plan currently is a minimum of 100 aircraft, but there's potential for that to grow, maybe 145, even up to 200. The idea is to properly replace the older bomber fleet.
And the cost. That's always the big question with these programs.
It is. The average unit procurement cost, or ATUC, is the number to watch.
Yeah.
Now, it kind of shifts depending on the baseline year you use for the dollar value.
Right, inflation and all that.
Exactly. So it was around $550 million in 2010 dollars, then $639 million using 2019 figures, and about $692 million in 2022 dollars.
Okay.
But the key thing to remember is that figure, the APUC, it covers way more than just the aircraft itself.
What else is in there?
You've got support equipment, training systems, spare parts, any engineering changes. It's the whole package deal, basically.
Right, a more holistic cost.
Yeah.
And payload. What can it carry?
It's designed for a really wide range of munitions, both nuclear and conventional options. So a mix of standoff weapons launched from a distance and direct attack ones.
And when do we expect to see it actually operational?
The target is sometime in the mid-2020s. So relatively soon, all things considered.
Okay, now the really exciting part for me, what actually makes this sixth generation? What are those capabilities, the features that really set it apart?
Well, the B-21 hits this critical combination. Amazing range, a pretty hefty payload capacity, and truly exceptional survivability.
Survivability meaning stealth, primarily.
Stealth is a huge part of it, yeah. But it's the combination that lets it penetrate even the most advanced air defenses out there and deliver precision strikes literally anywhere in the world.
Okay.
That 6th gen label really comes down to major steps forward in 3 areas. That next level stealth we mentioned, a big advantage in information gathering and sharing.
Information advantage. Like sensors and data.
Exactly. Advanced sensors, fusing data, networking. And third, that adaptable open systems architecture we touched on earlier.
Let's stick with stealth for a second. When you say next level, what are we talking about beyond just, being hard to see on radar?
It's way beyond just reducing the radar cross-section, though it does that exceptionally well. The B-21 uses advanced materials, its actual shape.
Yeah.
It's all designed to minimize its signature across a much, much broader range of detection methods.
Like sheet signatures. Electronic emissions.
All of the above. Infrared, electronic signals, acoustics perhaps. And importantly, a big goal is making this advanced stealth easier and less expensive to maintain compared to older stealth jets like the B-2.
Now that would be a significant change.
It really would.
And the open systems architecture, what does that mean in practice? How does it change the game?
Think of it like designing the plane using building blocks, modular hardware, modular software.
Okay, so plug and play, almost.
Sort of, yeah. It makes it much easier to slot in new technologies later on. It also encourages competition between different companies for upgrades.
So you're not locked into one specific vendor for the life of the aircraft.
Exactly. The Air Force can adapt the B-21 much more easily as threats change or new tech emerges. It should extend its useful life and hopefully keep upgrade costs down.
Makes sense.
And it's built to network across the whole battle space, talking to other planes, ground troops, ships, even satellites. Plus, it's designed right from the start with the option for unmanned operations.
Manned or unmanned, okay.
Right. And don't forget the coating. They call it a space-age stealth coating. Another layer to enhance that low observability.
Let's maybe step back a bit. Where did this whole idea come from? What drove the development?
Well, the program that led to the B-21, originally called the Long Range Strike Bomber, or LRSB program, kicked off in the early 2010s.
And the reason?
The main driver was simply the age of the existing bomber fleet. You know, the B-52s are ancient, the B-1Bs were getting harder to maintain, and even the B-2s were facing obsolescence issues.
Right, the B-2's getting on a bit now, too.
It is. So Northrop Grumman won the development contract in October 2015. They beat out a joint bid from Boeing and Lockheed Martin.
And the name Raider, that has some history baked in.
Absolutely. It was a very deliberate choice. Named in honor of the Doolittle Raiders from World War II.
Symbolizing that long-range, daring mission capability.
Exactly. It really evokes that spirit of American air power history. And to make it happen, Northrop Grumman put a lot of their own money in something like $2 billion just into building this whole digital ecosystem for design and production.
This digital ecosystem keeps coming up. It sounds like it was fundamental to the whole effort. Can you expand on that?
Oh, it's been totally transformative. This digital approach let them do massive amounts of virtual testing and simulation. They used production representative hardware and software really early in the process.
In labs.
In integration labs, yes, but also on a dedicated flying test bed aircraft.
A flying test bed. So not a B-21 itself.
Right. A different plane fitted with B-21 systems. That test bed flew over 200 missions, racked up something like 1,000 flight hours. They were testing actual production hardware and software way before the first B-21 was even fully assembled.
Wow. So ironing out kinks much earlier than usual.
Exactly. It massively sped up development and cut down risks.
What were some of the, concrete benefits they saw from doing it this way?
Well, they reported cutting the time needed to certify software in the lab by about 50%. That's huge.
60%.
Yeah. And flight test teams can analyze performance almost in real time now, which drastically reduces the time spent crunching data after a flight.
So faster feedback loops.
Much faster. And get this, apparently they only needed one software change in the entire first year of flight testing. That just shows how effective the early risk reduction work was, thanks to that digital approach.
That's incredible.
And on the factory floor, this digital system means everyone's working from the same playbook, the same single source of design and build info. It smooths out configuration management, improves communication between engineers and the techs building the plane.
And saves time.
They've said it cut manufacturing hours by roughly 1/3 in some areas. Plus, they're leaning heavily into things like augmented reality, advanced robotics, AI, the whole factory of the future concept.
Using commercial tech where possible, I read.
Yeah, leveraging commercial tech, but within a secure environment, of course.
Oh, boy.
It's all about driving efficiency and quality.
So from the virtual drawing board right through to the physical assembly line, technology is just woven into everything. What about the actual physical milestones?
Right. The first test articles came together at Air Force Plant 42 in Palmdale, California.
Okay.
The public got its first look at the rollout event in December 2022.
I remember seeing pictures of that. Very B-2-like, but different.
Definitely has that flying wing heritage. Then, the first flight happened November 10th, 2023, flew from Palmdale up to Edwards Air Force Base.
And that's where the main flight testing is happening now.
Correct. A really intensive phase of flight testing kicked off at Edwards starting April 4th, 2024. There were reports of the test force flying multiple sorties in a single week, really putting it through its paces.
And how's that going? Is the real plane matching the digital predictions?
So far, the word is yes. The performance data they're getting from the actual flights is lining up very well with what the digital models predicted.
Yeah.
That's a huge validation of the digital engineering approach.
Good news for the program.
Absolutely. They've also finished static testing, which basically verifies the structural design is sound. Fatigue testing simulating wear and tear over years of flight is underway now.
How many are actually flying or being built?
Right now, there are 6 aircraft in different stages of production and testing.
6 already, okay.
And another interesting tech point, they successfully moved the B-21's ground systems data onto a cloud platform.
Why is that significant?
It points towards potentially having a much smaller physical footprint for ground support equipment, less infrastructure needed on the ground, more flexibility.
Makes sense.
And it's important that the first test aircraft, the one actually flying, was built to be production representative. Same mission systems, same technicians, using the same tools and processes as the final production planes.
So no major changes needed when they ramp up production.
That's the goal. Minimize those kinds of transitions. And finally, on the production side, the government has locked in fixed price options for the first 21 aircraft.
Fixed price? That helps with cost control.
It does. And they have not to exceed pricing established for another 19 beyond that. It provides some budget stability, at least for those initial batches.
Okay, let's circle back to that 6th gen idea again. We talked stealth, networking. What other key technologies really define the B-21?
Well, the pervasive use of those digital engineering tools is really foundational. It touches everything from reducing risk in production to enabling modern, efficient sustainment down the line.
Right, the digital thread running through everything.
Exactly. Agile software development is also huge. It allows them to update capabilities much more quickly as threats evolve, rather than waiting for major block upgrades years apart.
More responsive to change.
Much more. We mentioned the advanced manufacturing, but they're also using things like a highly immersive virtual environment, HIVE they call it.
HIV, what's that for?
It lets maintenance crews visualize and practice complex sustainment tasks in VR before they ever touch the actual aircraft. Should improve training and reduce errors. And that cloud-based digital twin we talked about, it acts as the central hub for all the aircraft's data. Design, manufacturing, operations, maintenance. It's all accessible, fostering collaboration across the whole program. It really is designed, built, and sustained digitally.
It's clearly more than just a new airframe. It's a whole philosophy shift in military aerospace. So what's the big picture? What's the B-21's main job, its strategic role?
Fundamentally, it's about projecting American power and resolve. It's a key strategic deterrent aiming to keep the peace through strength.
The Fatesy speak softly and carry a big stick idea.
Kind of, yeah. Its ability to get through heavy defenses and hit targets anywhere is what makes it such a potent deterrent for the future. It's a critical part of the nuclear triad, offering a flexible and, importantly, a visible deterrent capability.
Visible how, if it's stealthy?
Visible in the sense that potential adversaries know we have this capability, even if they can't track the individual aircraft easily. Strategically, it's designed to guarantee America's air power edge against really sophisticated future threats.
Like advanced air defenses.
Exactly. Operating in contested airspace, overcoming those advanced anti-accessory denial or A2AD networks that's core to its mission.
And working with allies.
Definitely. It's designed for interoperability, providing flexible strike options when working alongside allies and partners in coalition operations.
Can it operate alone, or does it need support?
It can do both. It can execute missions independently, or it can act as a major force multiplier, working within a larger network of systems, pulling data from offboard sensors, other platforms.
Leveraging the network.
Precisely. And there's that future potential for autonomous flight, too, which could add even more versatility. Plus, beyond just dropping bombs, its sensor suite means it can also be a valuable intelligence-gathering asset over the battlefield.
Okay, so where will these actually live? Where are they going to be based?
The first main operating base, MOB-1, is Ellsworth Air Force Base in South Dakota. That's also where the main training unit, the FTU, will be located.
Gonna get ready for it there.
Oh, yeah. Major infrastructure upgrades are already happening at Ellsworth to prepare for the B-21's arrival.
And other bases.
Whiteman Air Force Base in Missouri, currently home to the B-2s and Dyes Air Force Base in Texas, are tapped as the preferred locations for the next main operating bases.
Okay.
The flight testing, as we said, is happening out of Edwards in California. And the long-term heavy depot maintenance planning is centered at Tinker Air Force Base in Oklahoma.
Sustainment is always a huge factor with complex aircraft. Keeping them flying, what's the plan there?
That was apparently a massive priority right from the design stage. The goal was to make it what they call a daily flyer, an aircraft that's highly mission capable and needs relatively minimal maintenance between flights.
Easier said than done, usually.
True, but they baked sustainment thinking into the design process. Those digital tools used in manufacturing, they're directly applicable to making maintenance more efficient, too.
Like the HIV system you mentioned.
Exactly. The HIVE, the digital ecosystem, it helps design for maintainability from the start. And that cloud-based digital twin will be vital for managing operations and sustainment throughout the B-21's life.
What's the goal for running costs compared to, say, the B-2?
The explicit aim is to have lower operating costs per flight hour than the B-2 Spirit, while also achieving higher readiness rates. A tall order, but that's the target.
Let's put it in context then. How does the B-21 really stack up against the bombers we have now?
Well, it clearly benefits hugely from lessons learned with the B-2 Spirit, but it takes things much further, especially with that open systems architecture and the next-gen stealth.
The B-2 is based on older tech now, I suppose?
Yeah, the B-2 program started way back in the late 70s, so its stealth technology, its avionics, its whole support and logistics structure, it's becoming dated and expensive. And remember, they only ever built 21 B-2s.
Right, a very small fleet.
Which makes each aircraft incredibly valuable and the loss of one catastrophic.
Yeah.
Planning for 100 or more B-21s really changes that equation, makes the fleet more resilient.
What about the B-1?
The B-1B Lancer. It's a powerful conventional bomber, but it's notoriously maintenance-heavy, it's aging, and it's barred by treaty from carrying nuclear weapons anymore.
So the B-21 replaces that role, too, in a way.
It covers the penetrating strike role, yes. And then you have the B-52, the BUFF.
Still going strong.
Unbelievably so. It'll likely serve alongside the B-21 for a long time. It's not stealthy, obviously, but it's adaptable, relatively cheap to operate, carries a huge payload. It might fly for 80 years or more in total.
Wow.
So the B-21 fits in as the high-end penetrating part of the force. And it's also, significantly, the first modernized leg of the nuclear triad, the bombers, the ICBMs, the submarines. The B-21 is the first piece of that puzzle to be updated for the modern era.
Okay, so it sounds incredibly capable, but no program this complex is without challenges. What are the potential hurdles for the B-21 going forward?
Cost control is always, always number one. We saw huge cost overruns with the B-2 program back in the day. Maintaining that target APC for the B-21 will be absolutely crucial.
And that cost depends on buying enough of them.
Right, exactly. If, for whatever reason, the planned buy of 100-plus aircraft gets cut significantly, the unit cost for the remaining planes could potentially skyrocket. That's a constant risk.
What else?
Adversary defenses aren't standing still. Countries like China and Russia are continuously developing more advanced air defense systems, S-400s, S-500s, future systems.
So the B-21 needs to stay ahead of that curve.
Constantly. It requires ongoing investment and technological upgrades to make sure its stealth and other capabilities remain effective against evolving threats.
And the bigger strategic picture.
Well, there's always the debate about how to balance investment. How much do you put into stealth bombers versus, say, hypersonic missiles or cyber capabilities or space? Ensuring the B-21 investment makes sense within the broader defense strategy is an ongoing challenge.
It's a fascinating balancing act. But overall, the B-21 Raider really does seem like a game changer for U.S. air power.
I think that's fair to say. It really represents a massive leap forward in military aviation technology. It blends that cutting-edge tech with a very clear strategic purpose, maintaining air dominance and projecting power globally.
Right.
Its whole development reflects, decades of experience in stealth and strike, and the aim is clearly to provide a really versatile, adaptable platform that can serve for many decades.
Well, that wraps up our detailed breakdown of the B-21 Raider for today. We certainly hope this gave you some valuable insights into what makes this aircraft so revolutionary. We'd love to hear your thoughts. If you have questions or comments, please drop them below.
Yeah, let us know what you think.
And if you found this discussion interesting, please share it with anyone else who might appreciate it.
Absolutely.
And of course, make sure you subscribe to the Military Breakdown Podcast so you don't miss our future analyses of critical military tech and strategy.
And check out our back catalog, too. We've covered a lot of other fascinating defense topics.
Thanks for tuning in.